All right, so good afternoon again. So in this session, as I said earlier, we will be looking at list. We will also be looking at we'll be looking at the C++ standard template library list. And from that, we're going to look at how we can develop our own list. Now, a list in C++, we are saying it's a dynamic type, in the sense that it's a sequence of elements that are normally connected by virtue of their memory addresses. And we're saying that the list can grow dynamically, in the sense that the list is not of a particular size. It doesn't restrict itself to a particular size. Unlike an array, a list elements can be added to a list dynamically, because the list grows in a dynamic manner. All right. Now, there are different implementations of lists. We have the single linked list, we have the double linked list. But first of all, we're going to look at the very basic of a list. We're going to look at how to declare one using the C++ standard library. And we are also going to look at how we can add data, how we can view the data from the list, and so on. And then, of course, you will make the comparison for yourself to see which is better, the list or the array. So the first thing we need to do is to configure C++ standard, the library. We need to configure C++ in order to use all the features that we want to use to implement this list. And just to ensure that you're a dev C++, the language standard is set to ISO C++ 11. Go to, let me bring up my screen. So we're going to click on Tools. We're going to go to Compiler Options. Then we're going to go to Settings. Then we're going to move to Code Generation. And beside where it says Language Standard, ensure that you have ISO C++ 11 selected. If it's not there, just click on the arrow here and select it. When you're finished, click OK. And then we are ready now to implement our list using the C++ standard library template. All right, so once you are there, let me know so we can continue working. Is everybody there?
Yes, sir.
All right, good. All right, so let me just a new tab so we can go through this together. All right, so we're going to be implementing a list here. And we're just using a template that already exists. When we're finished with this, we're going to look at how we can create our own. Now, in order to use the list from the C++ template, standard template library, we need to, first of all, include list. So we're going to have to say, include include list. All right, so we have to include list. That's a very important aspect of it. All right, so if we don't include the list, we can't actually use it, the list from the template. All right. So as I said earlier, we would use a list in a situation where we do not know the amount of elements to be collected. So for example, if you know that you're going to be collecting 10 grades from the students, you know that, of course, you could use an array, because an array of size 10 would suffice. But let's say you want to collect a list of all the, could be all the patrons at a party. you know, beforehand you would not know the amount of patrons who are going to turn up at the party. So if you declare an array of size 100 and you end up with more than 100 patrons, of course, the array would not be able to accommodate that. Are you following what I'm saying? So we use the array in situations where we know the amount of elements to be collected, right? When we do not know the amount of elements, a more appropriate approach would be to use a list, all right? Because a list can grow dynamically. Is that clear?
Yes, sir.
Sir.
Yes, sir.
Right. So for example, let's say this is probably crazy, but let's say a parent decide to make to store all the meals consumed by his or her child from birth up to probably age 10. You know, um, of course, beforehand it would be very difficult to calculate how many different meals the child would want to consume. All right, and so if he or she tries to create an array of a particular size, it's possible that it's possible that the child may actually consume far more. All right, so we use a list when we do not know the amount and where the amount may grow dynamically. So after including lists, the next thing that we do, we're just gonna set up our other components. So we're just gonna include IO stream. I'm including IO stream because I'm gonna be using C out, all right, and some other components. And we're gonna be using namespace std. All right, and I'm gonna do everything in main. All right, so first thing we need to do is to declare the list. All right, it's a template. So it means that because it's a template, we can declare a list of any data type. So we can declare a list of type integers, string, double, whatever data type we want to use. So I'm going to create a list of type double in this case. I could use integer. All right. So, all right, let me use int, keep it simple. So I'm going to say list, and then we specify the data type. That is to indicate that the list will comprise of integers. And I'm just going to use some whole number grids. So I'm calling this list grid. So here, this part indicates that we are using just integers in the list. And this is the name of the list. All right. And if we should compile this. All right, so far it's fine. All right. So this creates the list. So we now have a list. If you notice, I didn't specify any size for the list. All right. Now I can add any amount of elements I wish to add to this list. All right, so let's see. So if I want to add an element, all right, so if I want to add an element, I will use, all right, so that's my screen, all is well. And of course, if I wanted to declare the list to store double, I just put double here. Whatever data type you want, you just put it here. That's the point. I'm gonna put back in. All right, now to add an element to the list.
Sir, I can see the top, please.
Sure. There.
Yes, because I'm having an error, wondering why.
All right, so if we're gonna add elements to the list now, we can add the elements to the back or to the front of the list. So we're gonna put the name of the list first. We're gonna say that when you press the dot, you'll see a list of functions that can be performed. There's a function called push. So we have push back, push, push front. All right. The push back will add the element to the back. Push front will add it to the front. All right. So we're gonna say push back. All right. So we're gonna say push back. Other element like 20. So 20 is at the back. I'm gonna say grade. Push back. I'm gonna put 78. So far we have something looking like this. So we have 20 was originally at the back, then we put 78 at the back. So we have a situation that looks like that. If I want to add another one, I can just say grade that push back 95. Of course, that is gonna put 95 right here. So we're gonna have 95. All right, so that's the idea. All right.
So, sir, with the pushback, if you had 20 at space 4, then 78 would be at space 5?
I make sure I have the spaces as you are thinking of them. So let's say this is space 0, 1, 2, 3, 4. All right. So explain to us again. Go again with what you're saying.
If 20 is stored at 4, then
20.
78 would be at 5?
No, 8 would come behind. If you are pushing back, it would come behind it like here.
Okay, okay. So the 20 would remain at 4?
No. Oh, you're talking about it in that context. All right. So the positions are not fixed. All right. So let's say you have, it's like this. They keep shifting. So you have, say, let's say you have 20 first. All right.
Yes,
Even though you push back and it's 20, 20 is the first one. The 20 is gonna come here. But then if we keep pushing back, 78 is gonna come before the 20 here. All right.
okay.
And then if you push back again, 95 is gonna come here. But if we say push front, we're gonna put them at the front, at the other side of it. All right.
Yes, sir.
All right. So that's how we add elements, and we could add any amount. There's no limit to the amount that could be added. And then now If you want to see how many elements have been added, there's what is called a size function that will tell us the amount of elements. So if you want to just see, if you want to print the size of the list, you could just say something like that. Out grade that size. So size, in this case, size is going to be 3, because you have only added 3 elements. So this list is basically growing dynamically. If it was an array, of course, you would specify the size of the array beforehand. All right. Unless you're doing some dynamic allocation. So there is it. So we have 3 elements. All right. And if I should add another element, the size is going to increase to 4. All right. Now to print the content, all right, so if you want to print out all right. So if you want to print out the elements within the array, we can use the for range loop. And if you didn't modify the compiler, as I indicated to you guys earlier, you're gonna have a problem with this loop. All right, it doesn't work in the older standards. That's why we actually modify the standard. So if we have for, let's say we say for the integers I in grade. All right, so we can write the for loop like this. So for those, we can just print out the elements. So how this loop works is basically saying for I, so it's calling each of the elements in grade I. So for the i's in grade, right? So each time it iterates, the value of I is gonna change. So the first value of I is gonna be our element at the back. So let's see. So we're gonna say out I. All right. Let me print them the end line. I'm gonna print down or put /n, whichever one you prefer. So we could use that. All right, so there's no error, but let me just show you what would happen if we didn't modify this. All right, so if this wasn't changed, if the library standard wasn't changed to ISO C++11, of course, you would end up with some problem. All right, so here's its thing. It's basically gonna tell you that range-based for loops are not allowed in C++ 98 mode. That's why we had to modify it, right? All right. So if we run this now, we will see the different elements that are in the loop. So here's our list of elements. So the first element is 20, then 78, then 95. The 3 there is the size that we had printed earlier. All right. So let's just jump back. There. All right. So if we don't want to see the 3 on the same line, we just need to create a new line after we print it. Currently. We'll create 2 lines. All right, so those are the elements that we have. Any question on this?
So I would like to see the full program.
You'd like to?
See the full program.
Oh. And so that's it.
Yes, sir. Can you just do a little run through again from the pushback, sir?
All right. Good. So here we create the list. We declare the list here. And we're saying we use the pushback to add elements to the list. So we say grade that push. So we have the pushback and we have the push front. If you want to put something on the front, you would use push front. All right, but I just use pushback to keep adding them at the back. All right, so this method, the pushback method, that's what is used to add the elements to the list. If you want to add something to the list, you have to use the pushback method or the push front method. All right. Once you're finished adding elements to the list, the next thing to do, well, not the next thing to do, but if you want to see the size, there's a size method, just like how we have pushback to add to the back, push front to add to the front. There's a size method that will tell you the size of the list. That is, the size represents the amount of elements that are in the list. So if you have 5 elements in the list, the size will be 5 and so on. Then if you want to print out the elements from the list, we can use this for range loop where we use this simple setup. So we declare a variable here, I, that's going to be storing the elements from the list. So we are saying here that for int I, which is in grade, so for the elements in grade, and each of them will be stored in I, we're just printing them out. So I represent each element, and that print it out for us. Now, if we were to get information from the keyboard to store in this list, let's say I want to store, let's say I want to ask students for 2 grades to store in the list, or ask for some grades to store in the list. Let's see. Also want to store some scores in the list until, keep storing scores in the list until the user enter probably 200. Enter a score that is 200. So you could say something like while score is not equal to 200. All right, so we're gonna ask him to enter I'm gonna read the score. So this will read the score from the user. And once you read the score, the next thing is to put it in the list. So if you want to put them at the front or at the back, so us first to this side. And then we're gonna say grade that push. So I put it on the front. Put push front. And I just push front score. Right. But it's up to you how you want to add it. And then all right. Let me see if we're following. Based on this loop, how many scores will I be able to enter?
Any amount until 200 is entered.
Perfect. All right. So we can enter any amount of scores until 200 is entered. And the beauty about this, we are storing them now into a list. We could not do this with an array. If we're doing an array, we'd have to set the size of the array. All right. We'd have to store the maximum that the array can store. But for the list, we can store any amount. And here is it. It's asking me to enter a score. I enter 45, 55. I will be able to enter any amount of scores I want. And all of them are being stored. All of them will be stored. Okay, that's gonna fill up the screen. So let's put 200 now. 200. And there's it. So all the scores that were entered are stored. So these are the scores. If you notice the one that I hard coded, they appear here because I was pushing to the front. All right, so I was pushing to the front. So notice where the 45 is. All right, so the 45 is here. And we have 20 and 78. All right. All right, any question? Oh, here's 45. 45 is up here, the front. These are the back. So the front is up here, the back is the one. All right. Any question on this?
Yes, sir. No, sir. Sorry, can I go back on the program, please?
Sure. All right, good. So what I'm gonna ask you to do now, I'm gonna give you about 10 minutes. And what you're gonna do is you're gonna develop a program using list that will allow patrons at a party to enter their name, and their age. And you're gonna store both of them in. You're gonna use two different lists to store them. So you're gonna have a list that stores their name, and their name. You can just use the first name. All right, just use one of the names. So you're gonna use one list to store the names and one list to store the age. All right. and you're gonna stop receiving patrons whenever somebody who is 99 enters the party. So once somebody whose age is 99 enters the party, you're gonna stop receiving patrons. And I'm gonna type it up so you can see. I'm gonna share the script so you can work on it. I want to put you in some breakout rooms that so you can work on this. So let me just assign the rooms and the task to be done.
The age of 99 is entered, then the program should terminate. Right? What we did was make a while loop that stated that as long as the age is not 99, then the program will continue to ask the user to enter their name of the patient and ask the user to enter the age of the patient. Right? All right. So remember when I stated that I declared two variables, one for age of the patient and one for name of the patient? This is because right here, when you're asking the user to enter the name of the patient, what you're going to want to do is you're going to want to read that variable inside the name of the patient variable. And now, after you get that variable, you would want to put that variable and store it inside the linked list called the name of the patient linked list. Similarly, we would want to do the same thing for the age. So after you prompt the user to enter the name of a patient, then that age will get stored in the variable named age of patient, right? And then now this variable afterwards gets stored in the linked list that deals with the age of the different patients. So as I stated before, once the age is not 99, once the age is 99, then this loop will terminate. So once the loop terminates, then you would want to print the total number of patients that have been entered. And right here, we have it used as the name, as the size of the array. No, as the size of the name linked list. Right? So to print the total number of patients, we use the size of the name array linked list. So let's just run it and see what we have. So that asks for a name of a patient. Then now that asks for the name. Let's try 56. So now they're asking for the name of another patient. Because as I stated before, the program will continue to ask you for the name and age of patients until you enter the age of 99 for a patient. So let me not enter 99 as yet. Let me enter something else, like 78. Ask for the name of another patient. And now let's try 99 and see what happens. So 99 as the age, and then the program finishes. Right here we have 3 patients that have been entered. Any questions?
Okay, very good.
Yes.
All right, very good. Is there any question from anyone else? All right. Hope it's clear for everyone. Let me take another group. So that's Clay's group. Let me have Timara's group. Timara, go ahead, your group. please share.
Deidre was presenting on the screen. Could you take up your screen?
All right, so walk us through, Tony. I think you're muted, Tony. Please unmute.
Yes, the question asks us to provide a list for the name and a list for the age of patrons. That was done here. Then we move on to accepting the information from the patrons. So the question asks us to terminate if the person enters an age as 99. So we have while entry is not 99, we will do this. We will enter a name which will be stored in fname, and the name that is entered will be pushed back. And that is also done for the age. So if an age is entered as 99 now, then the program will move on to print the size of the list, the size of the name list, and the size of the age list, and also to print the elements of the list. Yes, that's it.
Perfect. Thank you very much. All right, any question for this group? All right, thank you very much for sharing. All right, so we're gonna continue at this time. All right, so we have looked at how we implement, how we create a list using the C++ standard template library. And now we're gonna be moving on. We're gonna look at how we can go about structuring our own list. And these are some of the things that we're gonna be looking at in order to create a background needed to implement our own list. So we'll be
Remember to share your screen.
reviewing. Thank you very much. So we'll be reviewing the concept of thank you. So we're looking back at the concept of abstract data type. We're gonna look at how to create a simple class in C++. We'll be looking at pointers, and ultimately we'll be looking at how we create a linked list in C++. So pretty much we're gonna be putting all of those together. So we're gonna put all of what we mentioned earlier together. That's the abstract data type, or pointers, put all of that together to create an abstract data type in the form of a linked list. Now, generally speaking, an abstract data type is basically a collection of data and a set of operations that can be performed on the data. So an abstract data type is basically a collection of data and a set of operations that can be performed on the data. We would have mentioned earlier the list abstract data type, and from what you did through manipulating the list, you should be able to tell some of the operations that can be performed on the list. Name one operation that you performed on the list that you used a while ago.
Finding the size.
Right, so it allowed you to generate the size. Good. And of course, I heard persons using pushback and push front. So it So the pushback allow you to put elements in there, right? So it allows you to put elements in there. And of course, there are other operations that can be performed. So if you want to select the first element in the list and the last element, so depending on how it is set up, you can get these things. All right, so there are different operations that can be performed on the list, on different data structures, abstract data types that we will be implementing. All right, so we're going to start with the list. Later on, we'll be looking at stacks and queues and so on. All right, so having mentioned abstract data type, we're now going to be looking briefly at classes and objects in C++. And by definition, an object is just something that has a state and a set of behaviors. All right, so an object is pretty much anything out there. Right now, we have objects before us, we have objects around us. An object is just a thing that we can identify a state for and a set of behaviors for. Just about anything that you want to write a program about. All right. Now the state of an object is represented by the attributes within a particular class. So the state represents the data that can be stored on the object, and the behavior represents sort of action that can be taken by the object. So for example, in the list, for the list object, we have things like, for the state, we would have like the data that is stored in the list with different data. And of course, the list may be empty, may be full, and so on. It can be in different state. There are different operations that can be performed. You can push data into the list. If you push data into the list, of course, that will make it, that can make the list, the size of the list increase and so forth. All right. We can generate like the size of the list by using a particular behavior. So there are different behaviors that are associated with our objects that we're going to be creating. And to create an object, we have to first create a class. And an object, if you look at an object as a building, before we create a building, we create a blueprint in the form of a building plan. So the blueprint for our object is the class. So the class dictates the structure of the object. It outlines the attributes and the behaviors that the object can perform. All right. So just keep it clear in the back of your mind that the class is just a blueprint of an object. It just set out the structure of what the object contain and the type of operations that the object can perform. And of course, to set up our linked list, we need to have a basic idea of a class and how the class is created, which of course you did in OOP, but we're just going to look at it briefly. And here we have an example of a class. We have a bank class, and of course we can have several instances of the bank account class. We can have an instance for John Brown, an instance for Bill Gates, an instance for just about anyone. All right, so you have normally have multiple instances of a class. All right. Now in C++, we create a class using the keyword class. They want to create a class called test. We say class test. All right, specify the name class followed by the name of the class. So if you want to create a class by the name test, then we put the name test after the keyword class. All right. Now the data that is contained within a class is going to be one of these types. It's going to be either public, private, or it's going to be protected. Elements that are public can be accessed from outside of a class. Elements that are private can only be accessed within the class. Elements that are protected can only be accessed within the class as well as through children of the class. So if a class inherits another class, then the protected members of the parent class can be accessed by the child class. All right. And here is a more detailed structure of the test class. So here we have a test class that is created with two data members. One of them is called X, one is Y, and we have a method here. This method test has the same name as the class. Let me see if anybody remember anything from OOP. The method in the class that has the same name as the class, what is it called? And it doesn't have any return type. It starts with C. A method in a class that has the same name as the class, what is it called?
Constructor.
It's a constructor, very good. So the constructor has the same name as the class. And the constructor normally, the constructor has to be in the public section of the class. So if you were doing Java, you would say something like public test. But because this is C++, there's a section for public, so we just put public colon, and all the public stuff come below here. For the private, we could just put private colon, everything private goes below here. All right. In terms of good practice though, you're encouraged to always put your data members as private. So like the Y here should really be on a private in terms of best practice. All right. Now, with the constructor is normally used to initialize an object of the class. And once you create an object of the class, the constructor is now called automatically. Constructor is called automatically once we create an object of the class. And we can have as many constructors as we wish. So you need to get this clear. So the constructor of the class always has the same name as the class, and it doesn't have any return type. So there's not gonna see anything like an int or void or anything like that before the constructor. All right, and we just use it to initialize the objects, the data. The data, which is the attributes, and which ultimately will initialize the object. All right. All right. And of course, a class may have more than one constructor, and I'll just take it through this. So we're not gonna go into much detail. So all I want you to understand now is that a class may have attributes, may have behaviors, and of course, class may have one or more constructors. So we're gonna look at this in C++, in the C++ before we move on to the other two concepts. So we're gonna just bring up our I'm gonna create this test class. So we are creating a class. So we start off with the word class. We call it test. Right. Then we're gonna create some private data members. All right. In X, then we have a public section. Then we have an int Y. Then we're saying test. This is the constructor, so I'm just gonna use it to initialize class. I'm gonna set each element to 0. All right, so we're gonna create a main method. And so this is our class, starts and end here, ends here. And here's our constructor that starts and ends here. All right. So we're gonna create an object of the class. So the object is the concrete implementation of the class. And in C++, we create an object by stating the name of the class is test. And then we specify the name like that. So this will create an object called T. All right, let's save this. All right, there should be no parentheses here. It's a typo. All right, so we have created an object here. The object is called T. All right. Now, even though you might not be seeing it, but once this object is created, X is set to 0 and Y is set to 0. All right. X and Y is set to 0. All right. If I want to see the value of Y, I can see it from here because it is public. So if I try to say print out T dot Y, it's gonna give me something. T dot Y is gonna be what? What's the value of Y?
0.
0. Everybody seen that? So Y is set to 0 here. So once this is executed, so let me run this. So there's it. So Y is set to 0 automatically. Now to further demonstrate that the constructor is called automatically, let me change this to 100. All right, so we're saying once you create an object of the class, the constructor will be executed. So now Y is gonna change to 100. So there's our output. So that just made the point that the constructor is called automatically when an object of the class is created. And that's what we need to know now. So once you create an object of the class, constructor is called automatically. So here's our class again. Our class comprises of data member X, Y, and a constructor. Down here, we created an object of the class. And once the object of the class is created, we are saying that the constructor is executed automatically. So this is executed automatically. Once you say test T, that is to create the object called T of test, the constructor here will be executed automatically. So whatever you put in here will be done automatically. All right. Suppose I had something like this. If I want to say cout new test. Right? Once I create this, it will run this loop. There's it, so it's saying new test. All right. So that's the point. The point is once an object of the class is created, the constructor is executed automatically. Hope everybody is seeing that. Any question on that so far? I'm gonna put back this at 0. Any question? Feel free if you're not following. Any question? All clear?
Yes, sir.
Gabriel, are you clear? Janelle, are you clear?
Yes, sir.
Right. Okay. All right. All right. So that's the very basic of a class. And from that we can build on that. So we have the attributes and we have our behaviors. So we could have other methods in addition to the constructor. But for now, we're just looking at the constructor. All right. And we're saying that with the constructor, once an object of the class is created, the constructor is called automatically. It's automatically called. Right? It's called automatically. All right. So we really need to understand these concepts in order to create our linked list. All right. Of course, within a given class, we could also have a constructor that takes in parameters, or what we call a parameterized constructor. This one didn't take in any parameter. As you can see here, within the bracket here, it's blank. This one takes in 2 parameters, one for x and one. What it does after is it set the value of x. So if the user enters 3 for x, x will be set to 3. If the user enters 4 for y value, y will be set to 4, and so on. So we have, just bring back. So we can add multiple constructors. So here's a second constructor. Here's a second constructor. Again, the constructor will have the same name as the class. We're actually doing what is called method overloading. So this one is taking it in a parameter. So I'm gonna call this xval, and it's taking in a y value. So I'm taking in 2 parameters. And all we're gonna do is to set the value of x to whatever the user enters. So x is equal to x1. And we're saying y is equal to y. Right. So this is another way to initialize the class. So if we're using this constructor to create our object, we'd have to say something like, right, so if I want to create another object, I'd have to say test. I'm calling it T2. Right. I'm gonna have to specify now the parameters that I'm using. Right. I'd have to say, right, whatever if I want to set them. Now, the compiler will know which of the constructors to use based on how the object is created. So this one is created without any parameter, and so this one will be created using this one. Because parameter was specified for T2, T2 would then be created using this one. Right? And so if we were to print out the value of say t dot y will be 0, but if we were to print out t2 dot y, we will get 330. Right? If I were to say cout t2, of course I'm going to say 330. So there's it. So the 0 is the t dot y and the t2 dot y is 330. All right. So if you understand the basic of the constructor within the class, then we can move on. All right, to creating our linked list. So the next concept that I remind you of, or refresh your mind, is the concept of pointers, right? And once you know about pointers and you know about the class, you can create your own linked list. Because remember, the linked list is dynamic in nature, in the sense that it can grow dynamically. It's not of a fixed size. So what happens is that you have one node being linked to another node, all right? And this allows it to grow as wide or as small as you wish, all right? So now a pointer from your structured programming class, you would remember that a pointer in C++ is basically a variable that stores the memory address of another variable. So the pointer stores the memory address of another variable. All right, so the pointer stores the memory address. So a pointer stores a memory address of another variable. And this is how we declare a pointer. So if the pointer is going to store the memory address of an integer, we're going to have to say int followed by an asterisk and the pointer name. If the pointer is going to store the memory address of a double, we're going to say double asterisk followed by the pointer name. So remember, a variable is just a named memory location. So each variable has a memory address that it's associated with. Each variable in the computer, just like each student right now on the platform, has an address. Each of you currently is connected through a particular public IP address. All right, if you want to put it that way. So each of you are at a certain location, which is identified by my device as a public IP address. All right. So we are now speaking through different public IP addresses. So you're at different locations. So similarly for the variables in memory, the variable represents different memory locations in memory. And we are saying that the pointer is a special variable which stores the memory address of another variable. And this is how we declare the pointer. So here's another slide that somewhat explains it more. So here we are declaring IP as a pointer, and this is a pointer to an integer. So the IP will store integers, the memory address of integers, of an integer. DP there, because it's declared as a double, can store the memory address of a double. And the same thing for FP, FP for float and so on. All right. So these names can be anything. All right, but the concept is that if the pointer is declared by a particular data type, it can only store memory address for that particular data type. All right. Any queries so far? Silence. All right. Now, here we have a variable called two variables. So you have a variable called total here, and we have a variable called sal. Each of them represents memory's area in memory. So the total represents a memory area where an integer can be stored. Sal represents a memory space where a double can be stored. Now, if you want to find the address where these values are stored, you would have to get the address by using the ampersand. So the ampersand, that is the and sign that we call it. So if we say and total, we're just gonna be talking about the address where total is associated with, that total is associated with. Now, as I said earlier, the regular variable will not be able to store the memory address of a variable. So if we try to say something like sal equal to ampersand total, that's not gonna work, because sal can only store a double value, but the pointer is able to store the memory address. Pointer is able to store the memory address. And remember, the memory address comes to us as a hexadecimal number. All right. So our memory address comes to us as a hexadecimal number. So let me just demonstrate so we can get a second view of this. So, so if we declare total as int, let's give it a value, double int. These are the pointers. So when you say star total DTR, we're declaring a pointer. All right. And let me just do something so you guys can see. Double. All right, so we declare two pointers, but we have not assigned any address to them. Right? We have not assigned any address to our pointers that we declared. So one of them is total PTR, and the other one is sal PTR. All right. Now the address that I want to associate with total PTR is going to be the address of total. So I'm going to say total PTR is equal to the address, the ampersand, of total. That means this is storing the memory address where total is located. And sal PTR is
Yeah, the sign should be there.
yeah.
And the sign.
Sign represents the address. Unsigned mean address of.
Okay.
So when we say and, we're saying the address of. So the address of. So the and is what we use to get the memory address. All right. So the memory address. So if I were to say something like cout, suppose I say cout and total, you're gonna see the memory address of total. Let's see. All right. So from your computer mathematics course, you should be able to recognize this number as a hexadecimal number. All right. So that's the memory address of total. All right. Now that will be the same thing as the pointer because the pointer is currently assigned total PTR is currently holding the memory address of total, which is here. There's it. That's the memory address of total. Right. Now, if I want to see the actual value that is at the memory address of the pointer, we can do what is called a dereference. We dereference using the asterisk. So if I put an asterisk before the pointer name, instead of seeing the memory address, I'm going to see the value that is at the memory address. So this is called dereferencing. All right, so here's it. So it shows me 90 instead of the memory address. That's how we dereference the pointer. I put an asterisk before the pointer. All right, so we are dealing with two things here. We're dealing with the pointer, and we're saying that the pointer stores the memory address of a particular variable. And we are looking at how we can dereference the pointer. All right, so our regular variables do not store the memory address. All right, the regular variables are just associated with a particular memory address and a particular value. The regular variables do not contain a memory address. All right, they are located at a particular address. So they all have an address, but they don't store it. All right. So if we try to assign Sal the memory address of another variable, it will not work. All right. Okay. Is this clear? Any question? Let me see if we're following. What I want you to do now, I want you to create a variable. Create a variable to store your age and create a pointer to store the address of that age variable. Create a variable that stores your age and create a variable that stores your age, and then you're going to create a pointer to store the address of that variable. I give you 5 minutes to do so and post what you came up with in the chat. All right, so we're now going to look at the linked list, and let's look at it from a diagram point of view. Here's the linked list. The linked list is made up of a set of nodes, and this implementation that we're going to be looking at, each node consists of two things. Each node consists of a piece of data and the address to the next node. And so that's how the list, the linked list is formed. Let's say we were to make a linked list and I tell you to hold somebody's hand. You can only hold one person's hand. All right, so in the single linked list, you would only be holding one person's hand. So if I tell Abigail to hold Abiola's hand, and then I'm gonna tell Abiola to hold Clay's hand, right? And next I'm gonna tell Deidre to hold Janelle's hand. I'm gonna tell Clay to hold Deidre's hand. I tell Maxam to hold Onika's hand. I tell Janelle to hold Maxam's hand. Now you as a node in the linked list, you will only know the data that you are storing if you're using the single linked list and the next person's hand that you're to hold. All right. So the single linked list, we store the node, that is the data Each node stores the data, a piece of data, as well as the next node, the node that is to come beside them. You have the double linked list that could store both the node to the left of the current node as well as the node to the right of the current node. All right, and so we normally use this block diagram to represent our linked list. So each node comprises of the data. The data in our, based on our example, for example, when we're doing the grade list, a particular grade would be the data. And then the next node, addressed to the next node, would be the next pointer for that. If there's no next node, the next node will point to null. So if there is no next node, like here, we'll have null. All right. So if you enter, like, say, 25 in the linked list and it's only 25 in there, then the next node is going to go to null. And so when we are going to insert something in the list now, the aim is going to be to find the node that has next pointer that is null. And next, you're going to add our new node to that pointer. And it's going to keep chaining like that. So think about it. We want to form a chain, could be like a human chain. So you know the hand that you're to hold. All right. You have a particular value, but you know the hand you're to hold. If there's nobody else to hold, nobody else to be connected to, the next person you're gonna be holding is gonna be considered to be null. Right? So next person will be null. So think about holding person's hand. So the first person to be selected for this chain, the first person will be holding nobody's hand. So the first person's, that's the first node. The first node's next node will be null because that person will not have any other person to hold on to. When a second person comes into the picture, then of course, the first person's next node will be that person. All right, and that new person's next node will be null. It's like when God created Adam. When God created Adam, the next human being after Adam was null. Right? When God created Adam, the next human being after Adam was null because there wasn't any other human being. But then he created Eve. And so the next human being became Eve. And so now the chain would consist of two nodes. So you have one that's pointing to Eve, and Eve is pointing to null because Eve, at the moment when Eve was created, didn't have anybody else. All right? So the human chain actually stopped at Eve during that era until, of course, they start procreate and so forth, and they keep on increasing. All right, so that's what the linked lists work like. So we can define the linked list as a linear data structure in which the elements they are not stored in what's called contiguous memory. That means they are not stored beside each other, immediately beside each other. Right? They are stored, they are connected based on the memory address. All right. So it's like even right now, we have a class. We have a class. You guys are in the same class. You're all connected, but you're not in the same physical space. But you're connected based on your address. All right. So we're saying that even though Janelle is not where Maxam is located, Janelle is still connected to Maxam. It's still a classmate of Maxam. All right. And we're looking at it in the context of a memory address here. So once you have the memory address of a particular node, you can establish a link to that node. All right. And we're going to look at the basic setup. And this setup will actually incorporate all that we looked at today. And it's not difficult, even if it looked new to you at first, but it's not difficult. by going through it a number of times, you'll get it. All right, so this is the basic setup. So the first thing we're gonna have to do is to create a class that represents a node. And who can tell me the two things that are gonna be in the node class? The node class will only have two things. What are the two things? Anybody would like to try? There are the two things in a node. There are two things in a node.
In a loan, sir?
Node.
Oh, no.
So they're saying that a list is made up of nodes. But what are the two things that you can see in the node here? Based on the diagram on the screen.
The data and the one that comes after it.
Very good. The data and the node that comes after it. So the node class is going to comprise of the data and the next node. So the next node is going to be the address of the next node. And since this is the address of the next node, what type of variable is going to store the address of the next node? Starts with a P.
A pointer.
A pointer, right? So we're going to use a pointer to store the address of the next node. All right? And we're saying the next node is going to be null if there's no other node coming. So each new node that we create, really, we're going to have a next node of null until it's actually joined to another node. So it's a very simple setup. All right, and let's get into it. All right, so it's what actually goes on behind behind the scene. So we're gonna look at it. All right. All right, so we're just making here a little comparison between the array and the linked list. And we're seeing that the size of the array is fixed as we would have established earlier. You know, so it would be difficult to grow and to shrink the array, right? But not so for the linked list. The linked list is really dynamic in terms of size. It can change, can increase, it can decrease as we would like. All right, so let's now look at the node class for our linked list. Very important class, the node class. Again, it's going to be called node. The class is going to be called node. So here we have the data. And the reason this is int, we're just setting up this linked list to store some integers. All right, we can make it more flexible. We could use some like a template to set it up so that the user could specify whichever data type, but we're going to keep it simple now just to get the concept. So int data, the data represents what the value that will be stored by this node, the value that will be stored in this node. And next, here we create a pointer to the next node. This is a pointer to the next node, and this pointer will store the next node that will be in the linked list. All right. So all of this that is here is what we have here. Is one of these blocks. So we create the data and we create the next node. That's what we have here, up there. All right. So the data and the next node. And of course, what is this called? What's this called?
Sorry, the construct.
Constructor. Very good. And it therefore means that once we create an object of the node class, this will be done automatically. So once we create an object of the node class, if we're using this constructor, we're going to be passing a value for data. And then if we pass in 10 for data, of course, data will be set to 10. All right. This data is basically referring to this variable here. All right, so it's C++ way of of identifying the data member that is associated with the object, all right, with the current object by saying this. So when you say this data, we're talking about this. Talking about the in data up here, the data here. But this the data over here is talking about the one here that is comes in as a parameter. If this the parameter enters in is 12, the 12 will be assigned to this data up here. So when you say this data, we're talking about this. So that will be assigned 12 automatically. But next will be assigned null. So the first node, or whenever you create a new node, the next will always be null. The next for the new node will always be null. So that's pretty much what the node looks like. That's all that the node, what the node looks like. So that's the node as a data and has a next. So let's go back at that. So the node doesn't get more complicated than this. That's all it has. That's a node. Now the list is comprised of several nodes put together. All right. So then when you're creating a list, now we're gonna be putting different nodes together. All right. So let's just create a node together. Let's all create it. Grab your compiler and let's create it. Let's do this together. I'll just do that right here. All right, so that's it. That's our that is our node class. All right, so that's our node class. Let's everybody have that. So you can compile it. Don't have a main just yet. So the node comprised of the data, next node, the construct. All right. Everybody have that? Everyone has that?
Yes, sir.
All right. Good. So think about it now. We're gonna make a list, and our list is gonna comprise of a set of nodes. All right. Now, if we make a list, all right, our list is gonna have a head, as well as it's gonna have a tail. Or if we want to call it, based on the library that we used earlier, we spoke about push what, front and push back, right? So the back would be the tail and the front would be the head, all right? The back would be the tail and the front would be the head. So we have the back and we have the tail. So the back, right? So our back would be like the last element added, and the front would be the first element added. Or if one look at it the other way around, right? But we have a back and we have a front, all right? Now, the list class is gonna be a very simple class, all right? It's gonna be a very simple class. Now, the first time we create a node, the first node that we add to our list is gonna be the head as well as gonna be the tail. Because if you only have one node, that is your head and that is your tail. Is that true? For example, if you only have one child, that child is gonna be your first and your last child. If somebody asks you who is your first child, you can say it's, say, Alex. And who is the last child? It's gonna be Alex because you only have one. Are you following what I'm saying?
Yes, sir.
All right. So now, so this is our node class. Let's look now at our list class. All right. So here's a very basic of our list class. All right. So here's a very basic of our list class. So the list class is going to contain a head and it's going to contain a tail. I remember the head is going to be a node as well, and the tail is going to be a node as well. So we have the head and we have the tail. We have the head and the tail. All right. Now, so these are the two pieces of data that your list class will consist of, the head as well as the tail. Now, if you notice in the constructor, when the list is just created, the first time the list is created, when you just create a list, the head is going to be null and the tail is going to be null. All right. So the head and the tail will be null. All right, because there'll be nothing in there, nothing at all in there. All right. So the head and the tail will be null. All right. All right. So let's create our list class as well. We're gonna add a few more things to the list class, but we're gonna do it gradually so we can actually get it. So of course, if I try to compile this program, it's not gonna compile just yet without the main. All right, and we need to include up here, we need to include our IO stream and stuff. So we should have this. So we're gonna create another class now called list. So we're gonna say list class is gonna have so the list class will have a pointer to the head and pointer to the tail. Right. In the constructor, we set both of them to null. The head is null and we're in tail. No. So that's what happens when you just create a class. You just create a list. So the brand new list will have a null head and a null tail. All right, and then we will modify them. So, all right, so this is the basic setup of the list. Now, the next thing that we need to look at is how we go about adding data to the list. You guys have done like the push method, right? I'm calling it insert, all right? But it's the same idea. So we have the insert or the push method, and we can decide where we want to push, all right? But let's look at how we do the push in this case. So here we are inserting data in the list. So if you wish to insert, say 5, if you pass 5 to the insert method, what's going to happen here is that we're going to create a node. We're going to create a node with the data that was passed to the insert method. So a node will be created, a new space would be created in memory to store this node. That's why we have new. All right, and then we generate a pointer to that new node, and that pointer will be in the form of temp. So we want to add a new node. So the first thing you want to do when you create your temporary node here is you want to check if the head is equal to null. If the head is equal to null, it therefore means that nothing has been added to the list as yet. And so if the head is equal to null, then we are going to say that the head is equal to the new node, and the tail is equal to the new node as well. All right. So the head in our case is representing the first element that is entered in the list. All right. Now, remember, if the head is null, it means that the list is empty. Because if you look from around here, when we just create a list, the head is null and the tail is null. So we're saying that if the head is null, that means it's an empty list. Then this node that we created here, so here we created a node, we have created a node and allocate a new space to store the node. So by saying node data, look, so when we say node and pass a data item in here, this is executed. So this data is set to say 5 if we put in 5 there, and next will be set to null. All right, so we're saying if once we create a new node here, we assign the temp pointer to that new node. So temp pointer is pointing to the new node that was created. All right, and we're checking here to do the insertion. We're saying if the head is null, that means that the list is empty. And so the head is going to be the first node that was created, which is temp, and the tail is going to be temp. All right. So head is going to be temp and tail is going to be temp. I remember temp is a pointer. So temp, the value of temp is a memory address. All right. And head and tail, they are pointers to the asterisk here. So that means they can store what temp is storing. All right. Notice the pointer, they're pointers. So these are pointers, pointers. All right, and sorry about it. So you're saying temp is a pointer as well. And so because head is a pointer, head can store whatever address temp is holding, and tail is storing that as well. All right, now if head is not null, it means that the list is not empty. So because the list is not empty, we're going to be adding the element at the tail. So we're going to add the element at the tail. So remember, each node has a next node, which represents the node that is coming after it. And so here we have tail next. So we're going to set tail next. to be the temporary node that was created. All right. So tail next is gonna be the temporary node that was created. So tail next represents the last node in the list. So tail next was the last node in the list. All right. And now, after we set tail next to be temp, what we do next is to indicate that the tail of the list, we indicate that the tail of the list is temp, because temp would be the last node entered. All right. So if the tail of the list is temp, now don't get confused. So once tail is set to temp, remember temp next would be a null node. If we track it back from here, when we create a new node, once we create a new node, this is where the new node is created. So the data is set to data, but the next is set to null. So down here, keep jumping. So when you say tail.next is temp, all right? So tail.next, before this line, tail.next was null. So we changed tail.next to temp, all right? And so what happens now is that the next node to tail is no longer null, but it now becomes temp. And now we indicate, because we are using tail and head to keep a track of the first and last node in the list. So tail equal to temp indicate that the last node is temp. All right, and that's how we add our elements to the list. So this is the basic for inserting the data in the list. All right, if it's not clear, I will encourage you to just go back through it. I'm just gonna type it up so we can actually see what's going on, and then we'll just look at how we print it and we wrap it up from there. All right, so the insert is gonna go within the list class. All right, so the insert, if you want to call it push, it's up to you. So it's gonna be void insert. And this is not the only way to implement it. This is just my way of implementing it. And of course, it's a valid way of doing it. All right, so node temp new node. We're gonna add a new node, so that's why we create a temporary node. And we're saying if the head is equal to null, that means if the list is empty, then the head is equal to temp, and the tail is equal to temp. Else, we're saying if this is not the case, then we are gonna assign the tail.next temp and the tail to temp. All right, so else. So that's how we do the insertion. All right, so even if it's not so clear to you at the moment, trust me, if you look back at it after we're finished, I mean the video will be available, so you can always go back through it. And if you have any queries, you can always ask. All right, so that's the insert. And if you understand the insert, everything else is pretty much simple. All right. Any question on the insert? We have some extra brackets. It should not be here. All right, so I'm gonna do a print method so we can actually see the output, because I know if I don't do the print method, I know we all have faith, but I know seeing is believing. So let's do a print method so we can actually see the output. And what the print method does, it checks to see if the head is null. If the head is null, that means there's nothing in the list to be printed. All right. And we're so once the head is not null, then we can continue with the printing operation. All right. But if the head is null, there's nothing to print. So that's why we say here that if head is not null, then we do a while loop. So while temp, and we just output temp data, and temp here is representative of a node, and we do a swap here. We swap temp next with temp, so we put temp next to be temp next. So we start from the head. All right, so the next node after the head is what goes into temp after, and we keep traversing the list like that. So the first thing to be printed here is head. Remember, head is pointing to something else. So if head has a next node, then the next node is going to be that node. And then it keep on repeating like that until it gets to the end. All right. And of course, if you wanted to print it in the reverse order, you start from a tail and so on. But let's just type this up. So void if you're printing, you still need a node for them. Saying that if the head not null, then if the head is not null, that means there's data in the list. If the head is null, that means the list is empty. You guys following that concept? So if the head remains null, that's from here. Remember, from here, when you just create a new list, the head is null. When you create a new list, the head and the tail is null. So if the head remains null, it means that there's nothing in the list. Are you following that?
Yes, sir.
I understand the null concept.
All right, good. So if the head is null, there's nothing in there. All right, so we're saying if the head is not null, then we are going to say temp is equal, and we're going to be traversing the list. So we're going to say while temp. While temp means while this is not null. All right, so temp is going to ultimately become null when it gets to the end of the list, because the next node, if you notice here, is a swap between temp is equal to temp next. At the end of the list, temp next is going to be null. So once temp becomes null, then that's going to be the end of it. All right, so that's going to become the end of it. So the logic is there. So, good. And if you understand the concept, you can actually make your own list algorithm. All right. So we're saying temp data. So we're outputting the temp data. So this is gonna put the data on the screen, and I'm gonna put them on new line and put it as so a comma between them. Semicolon. And then this part is what allows the loop to continue until temp becomes null. So we're gonna say temp is equal to temp next. All right. And that's the end of the while, end of the if, end of the print. I think I have extra bracket. All right. And that's it. Our list class has been completed. And to test it, we can use this main method to test it. And that's it. Let me just test it so we can see that it works. All right. So let me just create the main. Of course, you can go back through the slide. You can test it on your own. So a main turn 0. Let's go. All right. So first, I'm going to create a list called grade. And then that's my list called grades. And now, if you notice, now we can use it like how we use the C++ standard library one. So you can see grade that insert. I use insert, but you could implement it using push or whatever you want to use. I'm gonna insert 89. Grade that insert. Empty. And insert any amount you want to insert. And this is us creating our own abstract data type. Right? So earlier we look at how we use what somebody would have created. This is how we create our own. And at the end of it, we can just print. So grade, print. And that should be, there should be no error. If there's any, we will. All right, so that's an error from a bracket. So okay, semicolon. No, I need to remove this bracket. Okay, this is not finished yet. And then this is saying, oh, I use grade here and it's grades. I should use grades, grades, grades. Seem fine, no errors. Let's keep it. And this is it. So our lists actually work. So we inserted earlier, we inserted 89, 70, and 60, and we got them printed. All right. Now we can always add to this data structure to get things like the size of the list. You know, we could, if you want to get like the size of the list, it would be similar to what you do here to print. You just do a count within here. Instead of printing, you just count and if you output the data, or like you return the result. Yeah, well, that's something that you guys will get to figure out. All right, any question on this? That's it for me. All right, I'll make the video available, so and I will be open for questions if you wish. If you have any question, feel free to ask them. Look at the C++ standard library list. We look at the pointers. We look at the abstract data type. We look at classes, and we put it all together in through the implementation of a linked list. All right, so we'll pick up next week. I wish for you a good afternoon, everyone.
Sir, you can resend that code, please.
All right, no problem.